Thank you all for joining me. Welcome to beautiful Austin, Texas, or I guess you guys are all in Calgary or around that area. I was originally planning on being out there for my talk earlier this year, and I'm super bummed that I couldn't join you all. There it's something like 22 degrees Celsius, something like that. Here it's like almost 26 degrees, about 78 degrees Fahrenheit. So it's warm and sunny, and we don't have any snow. But I still miss it. I miss the fact that I can't be there with you guys in person. So I'm sorry about that. Maybe next year. But in the meantime, we're going to go ahead and do the best that we can with this virtual presentation on architecting for security in the cloud. So let's do this. Let me see if I can find there we go. Let's start out and I'll tell you a little bit about myself. I'm Josh Sokol. I used to be on the OWASP Foundation Global Board of Directors. I left probably about 4 years or so ago. I used to run the information security program at National Instruments, but the real reason why you want to see this talk is because I'm the founder, CEO, and CISO of SimpleRisk. And I did a lot of interesting things when I first started SimpleRisk, when I first got it off the ground. And we built an entirely cloud-native infrastructure for all of our customers. So that's really the intent of this talk, is to talk about how that happened. Now, when I talk about the cloud, it really depends on the shoes that you're walking in. If you're a customer, this is synonymous with software as a service. But if you're a hosting provider, that usually just means somebody else's data center, right? You don't have to keep the servers in your data center and have the network and things like that. You're just leasing space from somebody else. And so the challenge that I really ran into here is that my application, SimpleRisk, was originally built as an on-premise internal use application at National Instruments, the company that I work for. And later on, it was open sourced and released publicly so that people could run it. And the business of SimpleRisk hosting came about because we had users who didn't want to host it themselves. And so in that case, the cloud was really leveraged for agility. We wanted to be able to do this. We wanted to be able to spin servers up really quickly. We didn't want to have to buy hardware and things like that. But because of the risk and the compliance data that's being hosted in our SimpleRisk cloud, security ended up being a very big concern. So let's take a moment and talk real quickly about our SimpleRisk architecture, because that's kind of important here. So SimpleRisk is based on using whatever web server really you want. You can do Apache, Nginx, IIS, doesn't really matter. And the code for SimpleRisk is written in PHP. So all the stuff, there's some Java and some things like that, but most of the code is written in PHP. And then it uses a MySQL database as the backend. Now, I know what you're thinking. You're thinking, well, the code is written in PHP, so it's completely insecure, right? We're at a security conference, and that's automatically what people think when they hear PHP. So let me tell you a little bit about that. White Hat Security, very well known in the dynamic application security testing space, they do this annual report, and they had an interesting quote from the 2015 version. I've kind of followed it over the course of time, but this basically said, at present time, we can say that all of these aforementioned items, language, industry, organizational size, the development process, don't matter much, and if they do, it's only slightly under very specific conditions. So really what they're trying to tell us is that the things that are affecting the security of a program is really just, it's not dependent on the language. And White Source, which is an organization which does kind of open source analytics and things like that, they did a survey last year where they took the NVD database, the National Vulnerability Database. They looked at security advisories, GitHub issues, popular open source project issue trackers. And what they figured out was that of the 200 plus languages that database covered, they focused just on open source security vulnerabilities in the 7 top languages over the past 10 years. And their goal was to figure out which programming languages are the most secure, which vulnerabilities are most common in each language, and why. And a really interesting quote came out of that. They said, while the game of my programming language is safer than yours is certainly a fun way to pass time, finding the answer will probably not help you create the most innovative or secure software out there. So really what they're trying to tell us here is, hey, it really doesn't matter which language you're using. Um, there's no really one programming language that's better than another. It all just bases on the use case, what you're trying to do, what's your familiarity with a given language, things like that. And so for me, when I started out and was working with PHP, um, there were a few reasons why I decided to go with PHP to begin with. The first is because the same code works across lots of different platforms. I showed you that you can use Apache or Nginx or IIS. So because PHP is portable, it works on any of those different platforms. And installation is relatively simple. There's lots of instructions out there in terms of how to install PHP. It's very well supported. And there's lots of documentation for when things aren't that simple. So when you do run into issues, PHP, why doesn't X do Y? And boom, you have a nice list of Google results for all the other people who ran into this issue before us. And it's pretty simple to fix. And probably the biggest reason why I decided PHP is because, frankly, I knew PHP better than any other language. I'd done web development using PHP before that. And PHP for me was something that I was very familiar with. I could write code much, much faster and get to the thing that I wanted to do much faster since I knew it. So when we're talking about programming languages, and the things that we're doing, really it comes down to generic coding best practices, regardless of the language that you're using. If you're using C++ or Java or Python or Ruby, whatever your language of choice is, there are some very basic coding best practices that we need to adhere to. And so if you look at OWASP, for example, they have the OWASP top 10. Some of the things that start to come out of there are things like input validation, making sure that when somebody is entering data, especially if it's a user, an end user, that we are validating the inputs and verifying that they are what we expect them to be. You shouldn't put a quote in a field that's supposed to represent a zip code or an address, right? Things like output encoding to prevent cross-site scripting, making sure that we're taking that little less than character or the greater than character and encoding that into ampersand LT semicolon, right? And then hash and salt data used only for comparison. So this is speaking specifically about passwords. We want to make sure that when we're doing passwords for our application, that we are not storing the actual passwords in the database. We're hashing the password along with the salt, and then we don't have to actually store the password. When somebody goes and logs in, we just do that same thing with what they logged in with and say, does this match what we expect? Using things like industry standard crypto algorithms and not rolling your own, and then always checking for authentication and authorization. So Simplest had the benefit of starting from nothing. And obviously not everybody has that luxury, but even with that advantage, we're still continually evolving and we're still constantly finding newer and better ways of doing things. But in this presentation, really what we're going to do is we're going to build our defenses from the inside out. So picture that green field that everybody wants, and we get to start from there. So in our case, where we start with is our secure web application. So we've done the things that we expected to do in order to write the secure code. And now our first challenge is really ensuring that we stay up to date with the latest code and that we avoid number 9 on the OWASP top 10, which is using components with known vulnerabilities. So how do we keep the application updated? And really the answer here for us is twofold. The first is we want to keep the application in a GitHub repo. You can use any sort of source code versioning system. It doesn't have to be GitHub, but in our case, that's what we use. And there's a few reasons for that. The first is because you have access control over who can push out changes, right? Only certain people can check code into that repository. And even better, if somebody does check something into there, we're able to audit who did it and what they did, as well as when. And worst case scenario, if what they did was bad, we can roll back those changes very, very easily. We just, right click and roll back and boom, that thing was undone. So using that kind of source code versioning, the source code repository, makes it really easy to keep that application updated and make those changes if you need to. The second piece is really around the deployment, and that's using automation tools to check for updates and deploy. In our case, we use Chef, but if you want to use SaltStack or Puppet or whatever, it doesn't matter, right? There's all these different tools to do it. And the idea here is that your servers will know when new code is made available, and that code automatically gets rolled out to the servers. And having that kind of infrastructure as code automation process to roll those changes out means that our deployment mistakes, the risk of having deployment mistakes, are minimized. Anytime that you start to have individuals who are working off a checklist or things like that, things will get missed and it will not be consistent. But code is consistent. Code says, every time I do this deploy, this is what I do. This is where I get the code from. This is where I write it to, and so on. It also ensures that server configurations are consistent. So we can use Chef or whatever to update our configurations and make sure those are right. And you can even have different dev, test, prod environments, so different configurations depending on where you're operating. So at this point, we've kind of revised our architecture. Our architecture looks something like this. We've still got that secure web application, in my case, Simple Risk. We've got our GitHub repo, which is where the code gets pulled from. And then we now have an orchestration server, which is the thing that's kind of making all the automated things happen. So now we have servers, right? And at that point, we have to start thinking about, okay, how do we secure our servers? How do we make this work? And so when it comes to hardening the servers, there's some basic things that we need to follow. One is you can look at the CIS guidelines, Center for Internet Security. There's lots of guidelines that they have. They have baselines for secure systems and things like that. But some of the basics come down to patching, making sure that you are routinely patching the operating system and applications. And if you're in the AWS cloud, they have a really cool feature called System Manager Patch Manager, which will help you to identify patches that are missing on systems. It'll help you to apply those patches and push them out in a consistent fashion. If you don't, you can use that automation tool. You can use your Chef or Puppet, and you can automatically do updates via that tool as well. Obviously, turning off unnecessary services, things that you don't need. You know, we've heard for years and years that, hey, you shouldn't have Telnet running on a server, or, you know, shouldn't be hosting email server on a server that's running a web server, whatever. Things like that. We want to make sure that we only have the services necessary for our application. And then the last thing here is really, you know, how do we kind of shore up the system? And that's enabling a host-based firewall with default deny rules. So we're basically saying, hey, I realize there's probably network-based firewalls. Those firewalls are saying, hey, you can only talk to this app via port 80 and 443, only HTTP and HTTPS. But we also want to have a host-based firewall. And I'll tell you a short story about why this is critically important. We had, when I worked at NI, we had a system that was exposed to the public internet accidentally. It was a system that controlled our antivirus, handled all the deployments and things like that of our antivirus solution. And what happened was the network team was troubleshooting, and they dropped the firewall just to do the troubleshooting. And when they dropped the firewall, the system got accidentally exposed. There was no backup. There was no defense in depth. So without that additional host-based firewall, that system ended up being compromised. Somebody was able to figure out it had default credentials. They logged into it. And fortunately, they weren't able to figure out what exactly that system was for, because had they been able to figure that out, they could have deployed code to almost every system in our environment. So fortunately, we skated past that really, really bad thing. But it should be a constant reminder to you that you make sure that you employ those defense in depth tactics. In terms of administering your servers, there's a couple things that you can do here. One, highly recommend using a Bastion host. Bastion hosts are easy. You can basically create a server. This is the only server we're going to use to talk to all of our other servers. You can use firewalls to restrict the source for all inbound SSH traffic to that server, as well as to all the other servers. So all of your other servers are the only, they will only communicate with that Bastion host. And then that Bastion host really ends up being the only publicly accessible administrative interface. So what that allows you to do is to focus your time, focus your efforts in terms of security on that system. That doesn't mean we can completely ignore the other stuff, mind you. But when we focus our attention, we focus it on that Bastion host, and we make sure that's always up to date. We're always installing the patches. You know, we're monitoring the logs on that server and things like that. You can further lock that down via VPN. So you have to VPN in order to talk to the Bastion host, in order to talk to those other systems. You should disable root access. You should restrict sudo privileges on there. But you know, ultimately, you're creating one system as your focus point, and you're kind of bottlenecking any of the traffic to go through that. Now, this doesn't mean that people can't talk to your application outside that Bastion host. That connectivity still exists. We're purely talking about the administration side of things. Now, the other thing that we have here is AWS. If you're in the Amazon cloud, you have something called Session Manager. And this is kind of really super cool hotness, probably within the last year or so. They created this system where they effectively proxy your SSH sessions through AWS. And the result of this is you don't have to have publicly accessible interfaces. You only connect through Session Manager on your local system. You just install the AWS tools, you put your, you install the AWS client, you install your key into there, and then as long as the IAM functionality is configured properly, if your user has rights, it will be able to connect to that system. If it doesn't, it won't. So now you're able to get to this point where you're able to use identity and access management in order to control access to all of your different systems. And you can even take that step further and create groups. So certain users have access to certain systems while they don't have access to others. Really, really cool. So in any case, our architecture at this point, we've now added this Bastion host or AWS Session Manager, and that is the SSH access to this system. The next piece we really need to talk about, because Simplrose is an application that uses a database, is securing the database. How do we do that? And there's a few pieces that we kind of fit into here. One is using native database security. So in the case of MySQL, or really any database for that matter, we want to use long random passwords for our database users. We want to make sure that these aren't things that could be brute forced. Also, using least privilege for the database. And this is something that OWASP hammers on, and other organizations will talk about quite a bit. The idea of least privilege, making sure that you have only the permissions that you need in order to do your job, and you don't give it any more than that. So when you do a Simplrose install, as an example, we'll use the root account to create a new user that's a Simplrose user that has only the permissions that Simplrose needs, nothing more than that. So we try and get down to that least privilege approach. And the other thing that you can do here is you can restrict the host for the user to only the application servers. And what this does is it basically restricts that path of connectivity to the database so that only those app servers, the ones that are running the Simplrose application, are able to connect to the database on the back end. Now, the other piece here is AWS. And if you're using AWS or Azure or whatever, there's usually some kind of cloud-based security that you can apply here as well. And so in that case, you have things like security groups, and you can create inbound rules that also say only the application servers can communicate with the database. Now realize there's redundancy here, right? Because we already applied our host-based access at the native database level, but that's kind of the idea. We want to create defense in depth so that there aren't situations where if one control fails, now the whole system is compromised. Now, the other thing that we want to do here is not have a publicly accessible database. I believe that's the default configuration. It won't make it publicly accessible, but realize that if you say, yes, I want to give this database an IP address and I want it to be public, that's exactly what happens, which means that attackers on the internet can try and compromise it. If you don't have it configured properly, things like that, bad things can and will happen. So our architecture has changed a little bit. We now have introduced a database, and we have a MySQL connectivity between the application server and that database. Now, I want to push the pause button on our architecture for just a moment, because I think we need to talk about a fundamental concept in evaluating our system security. And that concept is called attack surface. So the attack surface is the sum of the different points or attack vectors where an unauthorized user, aka the attacker, can try to enter data or extract data from an environment. So I like to think about attack surface, and I feel like there's no better way to illustrate the attack surface than a castle, right? You look at a castle and you look at this castle, and the question is, how secure is this castle? And the answer is not very. Right? When I look at this castle, I can break a window, I can kick in the door, I can climb up onto the roof. There's probably plenty of places for me to get a foothold on this guy. I don't see any cameras out there. There's no moats, right? You guys get the idea here. And our goal with information security should always be to minimize the attack surface. How do we shrink that attack surface so that there's as few places that the attacker can attack us as possible? So let's take that same castle and let's add some walls, right? We put some big, tall walls around it, and we add some towers, and we put a gate there with a drawbridge. our castle is now slightly more secure, right? We now have our castle sitting in the middle. You could probably still kick in a door or break a window. Maybe there's still not cameras on it, but at least now we have walls around it, right? We have some additional mechanism of defense. And then we go and we go, all right, well, let's put some dudes at the top of these towers. And those guys will be archers. They'll have arrows. They'll be looking for threats that are coming our way, right? We've now stepped up our security slightly. And then we have boiling oil, right? We put those at the front gate so that when the guys come to try and kick down our door, we're going to pour some boiling oil on those guys and make them suffer, right? And then we go and we put a moat. And we have a big thing of water all the way around our castle gates so that anybody who's trying to get to it, they basically have to swim up to it and they're not in a very comfortable position to breach anything at that point. And then, the moat is full of alligators and freaking sharks with freaking laser beams, right? You guys get the idea. The goal here is to minimize the attack surface, right? All right. So now we can push play and resume. So the question right now is, what is our current attack surface? And we've since taken this approach a step further. We've laid out things like subnets for public, private, and sensitive. We've got the Bastion host, which was moved into an isolated VPC with access into another dedicated VPC environment. And we can do things like monitoring for traffic that transcends both of the VPCs. So we've taken this quite a bit further than that since I created this initial diagram, but you get the idea. So when we look at this, we have all the stuff that we did before, and that's all sitting inside of our virtual private cloud. And you can think of VPC as like a dedicated network here. And then we have some stuff that's outside of that, right? Our Amazon Cloud console is not within our VPC. And so if somebody can compromise that system, if they get my password, if you use MFA, if they figure out how to breach that, whatever, they can get to my Amazon console and then access those systems. Same thing with GitHub. If I'm grabbing my code and pulling it into my application from GitHub, now that becomes a attack surface as well. If somebody can compromise that, they can create problems for me. But our attack surface right now is actually pretty small, right? It's just those two things. And there's some things that we can do to prevent that, which we'll talk about more later. So our next steps here is really going to be, we need to enable access for our customers. They need to be able to use the application. So, security, if it's just inside of a brick vault or something like that, it's not going to be very useful. And then we also need to enable access for administrators. There's going to be things that they need to do on these systems. So with that, our attack surface widens a little bit, right? We now have a load balancer that acts as a proxy. This allows for our end-tier architecture, so we can actually scale out, have multiple different application servers that are communicating with the database. We still have those same other systems, our RDS for our Amazon database. We've got our AWS session manager, the Bastion host. We've got our orchestration server. But if you look at the lines that go from the red into the blue, this is effectively our attack surface. We have the GitHub thing, we have the Amazon console, and we now have the remote user. And the remote user is coming from the internet, and we have that HTTP, HTTPS to the load balancer. We still have to worry about that. That's a potential attack surface. And the SSH access, which hopefully we can cut off using something like VPN or that AWS session manager. If not, we still have to worry about that connectivity to the Bastion host. So when we think about attack vectors, how somebody would get in, we can break this down to a few things. The first is insider access, which would compromise our confidentiality, our integrity, and availability. The second one is an attacker compromising Amazon, and now they make some configuration changes to the environment. Maybe they're able to access systems via the console, stop systems, whatever. We have the situation where an attacker could compromise GitHub and they could push malicious code into the environment. We have the potential for an attacker to find a vulnerability in the application in order to gain access to the environment. That's that 8443 connectivity. And then we have the attacker finds a way to access the Bastion host. So because we've narrowed our attack surface, we've also narrowed the number of attack vectors. And when we have a narrow number of attack vectors, now we can actually plan our mitigations for each of these different attack vectors. So in this case, let's take the first one, the insider threat, and let's look at that. How can we fix insider threat? Well, the first thing is we can make sure that our insiders are relatively trusted, right? We can do background checks and make sure that there aren't any financial issues that would cause them to be subject to bribery. We can do things like limiting those who have access. I shouldn't give everybody, not all of my employees should have access to this environment, just the people that I trust, just the people where that's their role to do those things. In terms of Amazon, again, we should be limiting those who have access. I shouldn't give Amazon access to everybody. There's no reason my sales and marketing team need access to my Amazon console. We should have role-based functional authorization. So if there are users who need access to a certain set of functionality, maybe they're helping to administer servers, they probably don't need access to my database. They probably don't need access to my DNS. So we can have kind of role-based access. Ensuring that we have long and random passwords and setting the requirements in AWS to enforce as such. And then lastly, requiring multi-factor authentication. This is a security conference. You all know what happens when you don't have MFA on a device. We had a big issue a while back at NI where people were getting phished, and they would end up getting the password. They'd be able to log in, see their email, things like that. That completely stopped as soon as we turned on MFA. Because now, even though they got the password, which sucks, right? You still have to change passwords and things like that. They weren't able to access the systems. And that's really what mattered to us. So rotate the password, move on. In terms of GitHub, same kind of thing. We want to limit those who have access. We want to ensure long and random password requirements, require multi-factor. And then the last one here, audit changes frequently. Audit plays a big role in security, not because it's going to stop the compromise, but because it's going to help us to detect it. So when we're looking, we want to look for things that go on, understand the changes that are being committed, and make sure that they're appropriate. And you can do this with things like pull requests as an example, where somebody submits a request, somebody reviews the code and then says, yes, that looks good. Let's go ahead and push that out there before we actually roll things live. We also have the web application as an attack vector. So this is, in my case, the Simpress application or wherever you guys are running. And there's a few things that we can do here to help. The first is HTTPS by default. So redirecting our HTTP to HTTPS, that's obviously going to help to shore up the confidentiality of our connectivity, making sure that people aren't going to see things that are going across, like our cookies as an example. The next one is securing the HTTPS configuration. So not all HTTPS is the same. If you're using things like TLS 1.1 or SSL v2 or whatever, those are going to be worse off than if you're using newer versions of TLS like 1.2 or 1.3. So we want to make sure that we're using real SSL certificates, not self-signed certificates. Those are cheap or free in the case of Let's Encrypt. I would also recommend, if you're trying to do internal applications, we use something called SSL Mate. It runs about $100 a month for 100 SSL certificates. They're Let's Encrypt certificates. They rotate every 30 days. And it's a great way to make sure that you can run those. And it uses DNS as the authentication mechanism. So you can actually have internal, a domain, internal certificates deployed to internal servers using this tool. SSL Mate is what it's called. Also, we want to make sure that we're using TLS 1.2 or pretty soon it's going to be TLS 1.3 with strong ciphers enabled and honoring the cipher order. So we want to make sure that we're selecting the better protocols first, the more secure protocols first, before we have to downgrade to something else. Making sure that we have things like intrusion prevention or web application firewalls, and then just general application security best practices. So knowing our OAuth top 10, understanding how that factors into our application, making sure we're doing the input validations and things like that I talked about earlier. And then the last attack vector here is remote access. Remote access is basically how somebody is going to get into the environment. And so for here, we want to use long and random passwords for our SSH users. We want to use multi-factor authentication for the SSH users. Key-based authentication helps as well. So if you have a public-private key pair, you have to have that key in order to access it. That's a net positive. We want to restrict what IP ranges are allowed to talk to our Bastion host or our VPN or whatever. So we can kind of narrow that down to just these people are able to access this. And then disable SSH unless you're VPN'd into the VPC, Or that AWS Session Manager is pretty darn cool in this case because you're able to bypass a lot of this stuff. You can still use MFA in it and things like that, but it makes this whole process a lot easier. So with that, what recommendations do I have for you guys? The first thing is determine what is or is not in scope, right? You're gonna have a big application. There's gonna be lots of things that kind of follow around it. Figure out what all the things are that are in scope for your application and the things that are out of scope, or at least things that you don't control the security of. The next piece is creating a data flow diagram. So all those charts that I showed you along the way where I said this flows into this, here's the protocol that's using, things like that, that's a data flow diagram. And data flow diagrams are great ways to kind of understand how your application works, what are the components of the application, how data flows from one thing into the next. It's great when you're trying to troubleshoot, when systems are down, understanding how those components kind of fit together. But it's also great from a threat modeling perspective. We want to be able to look at our application and understand what are the things that are working, what are the things that aren't working, where our threats could come from, and then how to mitigate those. Which goes to the next piece, which is identifying the attack surface. What are all the places where somebody could attack that data flow? And then what are the threat vectors? Who is going to attack that, and how are they going to attack that attack surface that is available? And then the last bit here is planning mitigations to reduce the risk of the threat. So anytime we've identified threats to our application, we want to make sure that we've actually gone through and we have mitigations in place in order to reduce those risks. So with that, that is the end of the talk. Give me a sec so I can flop over to my browser and hopefully I can find you guys in here. There we go. So with that, let's see, does anybody have questions? I see a couple hellos, Hayes in the chat. I don't see any questions at the moment. Let's see, I'll give you guys a few seconds to throw stuff out there if you have anything. No, nothing? All right. So if you guys have any questions, you're more than welcome to reach out to me on Twitter. I'm at Josh Sokol. If you want to send me an email, I'm josh@simplerisk.com. Oh, we got another question popping up. The blog, by the way, so if you go to simplerisk.com/blog, I post all sorts of stuff on there. Usually it's relating to risk management and things like that. So we got one question here. They say, my question is related to multi-factor authentication. Now SMS is not that strong. What's the best way? Yeah, so kind of interesting note here, and this may be what they're referring to. There was a article that I read not too long ago where it was talking about a cryptocurrency, and somebody, I believe they were in the UK, they had literally millions of dollars of crypto in a wallet. Their wallet was protected via MFA, but they were using SMS as the MFA mechanism. And an attacker actually figured out how to clone their cell phone so that they could intercept that text message that they were using for MFA, and they were actually able to log in and transfer the crypto assets. And if you know anything about Bitcoin and things like that, once the money's gone, it's gone. So in this particular situation, there's nothing that they could do about it. But to the person's point and to their question, there's lots of other ways to do multi-factor authentication. So YubiKeys are awesome. If you get a YubiKey, you basically pop it in. It's like a hardware token. You can push the button, and then it basically puts your password into there. It will even do seeding and things like that. So the token will actually be constantly changing. You can use hardware MFA, so you can use RSA tokens. Those are pretty good. And in all honesty, even putting things on your phone, like a Google Authenticator, I really like the Duo one. They work really, really well in terms of doing that MFA, and they don't rely on those kind of outside protocols. They're seed-based, so you have a seed that the server has, and then that seed is basically what keeps it in sync with it. So any of those kind of tokens basically bring you away from those issues with SMS, which is really the ability to clone it and things like that. And then also, making sure that you have multiple factors of authentication. So having strong passwords and things like that. Yeah, making sure you have that. Let's see what Darcy says here. Strong MFAs, the classical definition factors mean something only you have are no. And yeah, that really goes to the point with SMS. If I can clone your cell signal, if I can be you, then I am you for all intents and purposes, and I can attack you in that way. Anything that doesn't meet strong isn't suitable for valuable assets. Absolutely, right? If we consider SMS to not be strong because it can be attacked in that fashion, that certainly isn't something that we want to use for example, millions of dollars of cryptocurrency. So we should understand when we're doing these things, there's MFA and then there's strong MFA, and generally SMS messages aren't considered strong MFA. Slava asks, can you guys have a copy of my presentation? Absolutely, I'm happy to share my presentation. I'll get with the organizers. Actually, what I'll do, I will keep this session open. I think I can do that. And if you give me a couple minutes, I will drop a link to my Dropbox where I have this presentation. You guys can download it from there. So unless if there are other questions, let's see, one last question related to VPN. If all my IT infrastructure is on the cloud, do I need a VPN policy? Is it applicable? So I would say yes. You should have policies for pretty much anything in your environment, because policies are basically setting these standards for what you expect from people. Are there things that you want them to do on the VPN, things that you don't want them to do on the VPN? Can they use the VPN for non-corporate traffic, things like that? So always having some sort of a policy on VPN is a great idea. And that goes for pretty much anything. We should have MFA policies and password policies, information security policies, things like that. So hopefully that answered your question. I don't know if that relates directly to the talk or if that was more general question, but hopefully that kind of gives you the answer that you're looking for. So everybody else, thank you so much for joining me. Really appreciate it.